continue with the implementation of the other functions of the set abstract data type. The next we will implement is the find function. So let's look at the documentation of the find function. It accepts a parameter, a value that we want to search, and then returns an iterator. So this is the value that we want to search and an iterator to the node which contains this value. So let's look at the return value. It says that an iterator to the requested element. If no such element is found, pass the end iterator is returned. So that means if the value is not found, we will return the pointer to the iterator to the past the end, past the last node. And past the last node is basically the dummy head node in this case. So let us implement this function. So the idea is very simple. We always start from the root node in a binary search tree. So we take a pointer to the root node, and as you can guess, it would be head.parent. So we will initialize pointer with head.parent. So it returns an iterator find and takes a value const t %v, and of course it would be a const function, right? And we start with the pointer set to the root node. So root node is stored at h.parent. So we start with the root node, and while we do not reach the end of the tree, so what would be the end of the tree? Let's say we want to search for 30. So we will compare 30 with ptr.val. So 30 is smaller than 50, we will move to the left side. 30 is smaller than 40, we will move to the left side. Now left side would be dummy head, so that means there is no node on the left side of ptr. So we just say while ptr is not equal to this dot h, right? So until we don't reach the dummy head. Now if we find the value, so we say that if v is equal to ptr.val, so in this case we got the value, we can set an iterator, define an iterator it, and we'll just store the iterator pointer in the iterator dot pointer. So we will store the address of the node in this iterator, and we just return it, right? So we return the iterator. Now the value can either be equal to the value of the current node, it can be smaller, or it can be larger. So else if value is smaller than ptr.val, what does this mean? This means that, let's say we are finding 40 and 40 is less than 50. Now in the next iteration we need to move this pointer to the left side, because if we were to find 40, it would be on the left side of the node 50. So we just move it on the left side. ptr is equal to ptr dot left, and if it is not equal, if it is not smaller, then it must be larger than the value. And let's say if we are at node 40 and we want to search 45, so we will move pointer to the right side. So we just set pointer is equal to pointer dot right. Now there are two conditions when we can get out of this loop. One is we find the value, put the pointer in an iterator and return that iterator, or we move left, right, and ultimately reach the end of the tree, that is the dummy head. In this case, this condition boolean expression for the while loop would become false, and we will get out of the loop. Once we get out of the loop, it means that value is not found, right? So we set the pointer to dummy head. So we are saying that dummy head is basically past the last value, past the end. So we just store the address of dummy head in this iterator, and we return this iterator. So this is the find function. If you were to use it in the client code, we can search for a value. So the tree contains these three values. We can say iterator. We define an iterator now. So we can say that we define an iterator. So set type integer iterator it is equal to t dot find. Let's say we want to find 45. In this case, we should get an iterator to the value 45. So we say that if it is not equal to t dot end, we have not defined t dot end yet, we can define it quickly. So if it is not equal to t dot end, that means this value is found, and we can get the value using the iterator. So we can say that static it found, right? And if it is not found, we can say that the value is not found, but in that case we cannot use the iterator, because iterator would be containing the address of the dummy head node, and its value part just contains garbage. So we can display the message value not found, right? Now the end function, it basically returns the iterator to the dummy head node. So we can implement it iterator, and it would be a const function. It is not changing anything. So we take an iterator it dot ptr is equal to this dot h, right, and return it. And in case of, we can also implement the begin function. So how would begin function work? So it would contain the address of the first node, and we know that the address of the first node is stored in the parent of the dummy head node. So we have implemented the begin and end functions, and we have not implemented the not equal to operator for the iterator. So we need to overload the not equal to operator as well. So boolean operator not equal to const iterator right hand side const. So we just need to compare if the current, if this iterator, that means iterator on the left hand side of the not equal to operator is not equal to the pointer or iterator on the right hand side of the not equal to operator. So we just compare their pointers. So we say that if this dot ptr is not equal to right hand side dot ptr, whatever the result of this expression, boolean expression is, we return that. So if pointer on the left, pointer of the iterator on the left hand side is not equal to the pointer of the operator on the right hand side, we just return that. And we can similarly implement operator equal to. Now let's see if this code compiles. So it is compiled. Let's run it. So we called the find function with 45, and we got the message 45 found. And let's say if we want to find let's say 30, which is not in the list, we can compile the code again, run it, and it says value not found, right? So the find function is working fine.